Hello, everyone, and thank you all for joining today's DH2I webinar, Overcoming the HADR and Networking Challenges of SQL Server on Linux. My name is Connor Cox, and it is my pleasure to be joined today by SQL Server MVP, Joey D'Antoni. Before we get started, just want to quickly point out that from your GoToMeeting control panel, you can submit any questions you have using the questions pane there. And then at the end of the session, we'll go through as many of those questions as we have time for. So with that, I'd like to hand it over to Joey D'Antoni to go ahead and discuss HA for SQL Server on Linux. So thanks, Joey, take it away.
Thanks, Connor. I really appreciate it. And hi, and welcome, everyone. This is one of my favorite topics because I really like SQL Server on Linux. I think it's a great concept. I've been working on it since well before it came out. We were under some NDA programs with Microsoft, and back when it was called Project Helsinki, which is where Helsinki is where Linus Torvalds from. So that was the internal code name at Microsoft. But I think there are a lot of really fantastic things about Linux. But as I blogged pretty early along in the process, I think before SQL Server 2017 even went GA, one of the challenges I had, and we're going to talk about this today, is the high availability and disaster recovery story. So Microsoft supports a number of solutions, and we're going to be talking mainly about DH2I today, but the solution that's fully documented and used is called Pacemaker. And Pacemaker was kind of originally designed as a service for high availability amongst web servers and stateless servers. So transitioning that into a database model is a little bit more challenging, and definitely from a configuration standpoint and a management standpoint, it's a lot harder than our traditional Windows Server failover clustering workloads. In addition to that, I feel like there are a couple of other gaps that has. So right now, Docker just doesn't really have anything beyond. So we're going to talk a little bit about containers. This will be the only time I talk about them, which is another thing I really think is a great technology, but also lacks in that high availability in DR space. And DH2I can support that high availability model within containers and keep your data going across containers. In addition to that, it can make just the whole process of configuring availability groups a lot easier. We'll walk through a demo and kind of see that later in the webinar. So as Connor mentioned, I'm a Microsoft Data Platform MVP. I'm also a VMware vExpert. I've been working with SQL Server for just over 20 years now. This is probably my 21st year of working with the product. I've worked with it since version 7, all the way through 2019 and in various Azure incarnations. You can find me on Twitter at jdanton, and if you have any questions after the webinar and you want to hit me up there, feel free to go for it. I'm also a principal consultant at Denny Cherry & Associates Consulting. And I blog at joeydantoni.com, and I write a monthly column for Redmond Mag. So those are kind of all the places you can find me. I had the good fortune of speaking about SQL Server on Linux at Microsoft Ignite in 2017. So the year SQL Server 2017 came out, I got to talk about it at Ignite. And I told Denny, who owns the company I work with, and that I never thought I would see the day, like back in 2013 or 2014, that I would be presenting at the biggest Microsoft conference from my MacBook Pro about SQL Server on Linux. But really, since Satya Nadella came in and the company started being run by engineers, more so than sales folks, no offense to sales folks, but it was just kind of a change in mindset when that came in to Microsoft. There's been a big shift more towards open source software. I mean, Microsoft bought GitHub. And the reason why they brought SQL Server to Linux was just to make the product more accessible to more users, because they see a lot of developers coming out of colleges who have only ever worked on the LAMP stack, which is Linux, Apache, MySQL, and PHP. That's a common scenario, and I work on MySQL and Postgres as well, and I will say they are not as full-featured databases as SQL Server. So having solutions available in the Linux space that broadens the number of people they can sell to, And honestly, it was a great engineering effort to do it, but it was less work than I would have thought it would have been. It wasn't easy by any means, but the way Microsoft did this was by building a platform extension layer. So the code that runs SQL Server is effectively the same on Linux and Windows. There are some minor changes, but it's still just SQL Server, which is really kind of awesome. So the other benefit to this is you can run on the platform of your choice, and DH2I supports all of these platforms, so Linux, Windows, and Docker, and you can run on the Linux of your choice. So you can use Linux, you can use Ubuntu, which is what I'm going to be demoing today, or you can use Red Hat Enterprise Linux. Those are the supported features or supported options. One frequently asked question I get about SQL Server on Linux that I always like to talk about, because it's a proper topic. It's a good topic and it costs money and people are always concerned about money, is how is SQL Server licensed on Linux? Is it any different from Windows? And the answer to that question is that it's licensed exactly the same way. So for Enterprise Edition, you buy it by the 2-core pack, and the 2-core pack costs roughly $7,000. Or excuse me, $14,000. It's about $7,000 a core. And so it's the same as on Windows. And honestly, if you look at the pricing of Red Hat Enterprise Linux versus Microsoft Windows Server, that's about the same pricing. I have a blog post on it, but they're within like $100 of each other. And compared to the cost of SQL Server licensing, it's trivial. The one place I might mention that it can be a big difference in cost is if you're on a very large server and you have to buy Windows Server Data Center Edition. So like if you have crazy workload and you have 64 or 128 cores, Linux can be a lot more cost effective in that scenario. So from an architectural perspective, and as an architect, I always like to think about cost. That's something to be aware of. Containers, whether they be Docker or Kubernetes, in terms of licensing, are exactly the same as if you had SQL Server on a VM. So SQL Server VM licensing is kind of twofold. You have one option that only exists if you buy Enterprise Edition with software assurance, which is unlimited virtualization. So that means you license all the physical cores on however many boxes you would like to run SQL Server on. So in that case, if you had 3 boxes with 16 cores each, I'm going to make myself do math on the fly, and you would do 48 cores of licensing. But you could run as many VMs as you wanted to. You could even over allocate. I wouldn't recommend that, but you could allocate 64 cores of licenses and you'd be fine. The other option, which is what you need to do if you're not using Enterprise Edition or you don't have software assurance, is you just license each VM individually. So if you build a 4-core VM, you license 4 cores. If you build a 2-core Docker container, you license those 2 cores. So from that perspective, it's pretty much the same. The other thing I'd tell you is that almost always with Microsoft now, you want to buy software assurance, especially on this topic. Microsoft for SQL Server 2019, and even if you're not running SQL Server 2019, since SQL Server 2019 is available, these are the license terms that apply. If you buy software assurance, you can get up to, I think, 2 or 3 extra copies free. You get a high availability copy that's free if you don't use it, and a DR copy that's free. Just for the cost of your one license. So Microsoft has made it really attractive to have high availability. And the other thing is software insurance that entitles you to newer versions, and Microsoft is releasing quite frequently. So there's a lot of benefit to that. So we're going to cover in today's talk, I like to have a couple of slides before I hit my agenda slide, that's why. So we're going to talk about, we've kind of mainly talked about SQL Server on Linux benefits, but I'll touch on that a little bit more at the end of the slide. We'll talk about SQL Server high availability and DR options just in general. They're pretty much the same on Linux as they are on Windows. We'll talk about Pacemaker and some of its problems. I had a real great deal of frustration around using Pacemaker, and I know I tried to help Microsoft refine some of the documentation around it, as did another one of my MVP colleagues, Alan Hurt, and it's really challenging software to use. I know some folks have done a lot of work with Pacemaker in terms of Linux use, but I thought it was really challenging, and I have a pretty strong Linux background. I was an Oracle DBA when I started, so I have a pretty solid background in that space. Then we're going to talk about DH2I and how it fits in and how it builds out a solution for you. And then we're going to walk through a demo. Part of that's going to be video and part of that's live. I recorded the video this morning just so I could get the timing down, but the timing is actually slowed down a little, but I pretty much had a new cluster built and added databases to an AG within 5 minutes. I'm pretty impressed at how easy it is to configure this tool. So before we talk about HA and DR options, I just wanted to kind of expound a little bit on the benefits of running SQL Server on Linux. I mentioned cost earlier, and generally speaking, unless you're on a very large server, that's not a big deal. And even so, the cost of Windows Server relative to the cost of SQL Server is also pretty trivial, even when you're buying data center. The real benefits I see from running SQL on Linux, the biggest is just around automation. The install process of installing SQL Server on Linux is integrated into your package management solution in your operating system. So if you're on Red Hat, that's Yum. If you're on Ubuntu, that's apt-get. You can also do a lot of after-the-fact customization using MS SQL Conf, which is a kind of a binary that Microsoft has created that allows you to kind of change things dynamically. I think it's a really good solution for automatic installs, and it's something. The install process of installing SQL Server on Linux takes a minute or two compared to, I did a lot of work. I used to work at Comcast, and one of the things we built when I was there was a private cloud. And with all the work we did with SQL Server, to get an install down to about 10 minutes took a lot of work, and took us deploying on VMs that were temporarily deployed to flash drives so we could write faster. The process setup.exe has had some additions, but it hasn't changed significantly since the SQL 2000 days. So it's kind of a big, ugly, old process. The other thing is just if you're a shop that does not do a lot of Windows Server work and you want a robust, mature enterprise class database, SQL Server is a good way to go. The big advantage, there are a number of big advantages it has over MySQL for sure. Postgres can compete, but when you use Postgres, you have to compile or combine a bunch of additional projects that you load into the database. And believe me, there are some places where I feel like Postgres can be a little bit stronger than SQL Server, but in general, SQL Server is a pretty mature, robust database, and you get professional support from Microsoft. But so the real benefits I see are ease of installation and flexibility in platform. So the ability to run on any platform. And unlike Oracle on Windows versus Oracle on Linux, it's the same version. So you can back up and restore databases between Linux and Windows. We'll talk about high availability between the platforms. You can do that as well. Yet just yesterday, I was on a customer machine, and I'm trying to write some queries against execution plans. So I'm doing some fun X-query stuff. And I was able to take a clone of a database on a production server, upload a backup of that clone to Azure, and then download it to my MacBook and load that clone database, which just really had the query stored data, into a Docker container running on my MacBook. So just lots of flexibility, and that's kind of the direction that Microsoft is generally headed, but it's nice to know. So when we talk about SQL Server failover or high availability and disaster recovery, one thing you'll note I don't have here is the term always on. The always on term is kind of a marketing term that Microsoft uses to group some of these features together, particularly failover cluster instances and availability groups. Failover cluster instances are a little bit old school in kind of a modern cloud world. I think it's less attractive of a solution because it's dependent on shared storage. And there are ways that you can build shared storage solutions in the cloud. There are some third-party solutions that allow you to replicate disks to make them appear to be a cluster disk. Windows Storage Spaces Direct can do that, but it doesn't work real well in the cloud because there's not enough network bandwidth to transfer the traffic. When we talk about failover cluster instances in the cloud, it's typically to support a legacy database or a legacy instance that only supports failover cluster instances and non-availability groups. However, there are a couple of benefits that I'll mention in the cloud, and we'll kind of talk through them on the next slide, but the biggest one is you only need to have one copy of your storage. So if you have a lot of storage, you can save some money that way. But in general, I like to recommend availability groups, which we'll talk through in a little bit more detail, but these were introduced in SQL Server 2012. The solution has been maturing since, and it's effectively the platform Microsoft uses for Azure SQL Database and Azure Managed Instance. They do things a little bit differently. They don't involve clustering, but what that means is it's continually getting active development to improve the features. So availability groups are kind of the more robust and preferred cloud solution, and that's what we're going to demo today, since we're talking about AWS and how easy it is to get up and running. The other two features I like to talk about, they're less robust in terms of what you have to do to fail over, but they can give you data protection. So log shipping is still one of my favorite features, especially for migration purposes. Log shipping is simply the process of having a secondary database on another server in standby mode. You get the logs over to that server, whether it's a shared volume, some copy command, or even carrier pigeon, and apply them to the database to keep that database relatively in sync with your production copy. The one big advantage log shipping has over these other features is that if a user makes a mistake, like runs a delete statement without a where clause, and you delay your log shipping application, which you can do, so you say don't apply the restore in real time, wait 3 to 5 minutes. That can protect you against that accidental deletion of data, and that's something that log shipping can do that these other two solutions can't. It's also a little bit more tolerant of transient network failure is the term I would like to use. So if you have a shaky network, availability groups probably aren't the best solution for you. Log shipping can be a better solution there. In replication, I like to loosely cover here because replication in SQL Server is kind of object-based. So we have publications, which are typically groups of tables. Replication, in my opinion, is better used as like a secondary reporting solution, but it can be used to protect data, especially if you're maybe trying to protect a critical table, and it can be a lightweight mechanism in order to do that. The other advantage that replication has over the rest of these solutions is that with availability groups, log shipping, and replication, we can, in some form or fashion, read the secondaries. With availability groups and replication, we can completely read our secondary copy. In log shipping, you have to bring the database online and then apply another log. With replication, you can add additional indexes for reporting. So it's kind of the best solution for reporting, although availability groups are I'd say are easier to implement and manage because the tooling is a little bit more robust around AGs. So failover clustering, the big gap that availability groups have to failover cluster instances, and over the last 8 years that availability groups have been a thing, I think most DBAs have figured out workarounds to the solution, but is that MSDB and master are shared between nodes of the instance. There's actually only one copy of the database files and transaction log files, and it's stored on shared storage. Now, in a cloud world where you may have storage replication, you may actually have 2 copies of the data, but functionally there's only, as SQL Server sees it, there's only 1 copy of the data. This means you don't have to worry about keeping logins and jobs synced across servers. There are a number of other ways you can do it. I use, there's a really great open source project that's run by some of my fellow MVPs called DBA tools that have some solutions to do this. So in most cases, I use that just to sync logins and jobs every hour or so. But this simplifies that process. So these are only good for local high availability. You can do DR with storage replication, but it's really messy and I wouldn't recommend doing it. The most common scenario where I still see these is back when, and this is pretty less common now that we're in such a cloud world, but when you're running on physical hardware with a SAN, and when you only want to manage a single instance. And just to kind of show you how the architecture looks, this is a little bit different on Windows. It's very much conceptually similar to SQL Server failover cluster instances on Windows, where we have our 2 nodes. One of them is active. In this case, we have our clustering software, which is Pacemaker, and which is the clustering software, and CoroSync, which is the quorum software. So the hardware here is Linux. We have Linux servers in front of our shared storage. Typically, this is done using NFS storage. In the implementations I performed, I've created NFS shares that are hosted by a file server. But there are a couple of other ways to do the storage, but the main point is you have some element of shared storage. The service floats between the nodes as it fails, and it just kind of works. The pacemaker bit and the CoreSync bit are a little bit challenging because there's a lot of certificate management. We'll talk more about some of their faults later, but that's the general notion of a failover cluster instance. So this is definitely what I would consider kind of an old school way to do things. And if you're building out new infrastructure, I'd be hesitant to do it. DH2I does support you building shared storage, and it fully supports shared volumes and all of that stuff. It's just I would typically in a more modern architecture recommend going with availability groups, which is our next slide. One of the really cool things we can do that might be more theoretically cool than practically cool is that we can have a cross-platform availability group. So availability groups support a few different types of clusters. This started with SQL 2017 when SQL Server on Linux came out, but beyond Windows Server failover clusters, SQL's availability groups supported a cluster type of external. This cluster type of external allows us to use a product like DH2I or Pacemaker in Linux. And what DH2I can do is create one cluster that spans Windows and Linux. And I always kind of question the practical benefit of doing that, but it does protect you against any sort of weird OS failure where one single OS went down. But this can also be a good scenario if you're migrating a database solution off of Windows and onto a Linux solution. It can make it quite easy to do that. The other option to do that is using distributed availability groups, which is a feature that was introduced in SQL Server 2016. The easiest way to describe that is as a cluster of clusters. I know that's a little bit confusing, but I'll give you a use case for distributed availability groups. I had a customer who had an office in the Netherlands and another office in the Philadelphia area where I am today. In a single availability group, which is very much possible over that distance, they had local high availability. So basically they wanted 2 copies in the Netherlands and 2 copies in Philly. In a normal availability group, what would happen would be if the primary was living in the Netherlands, it would send 3 streams of data out. It would send 1 to the local replica and then 2 streams to each replica in the US. With a distributed availability group, those would be 2 different clusters. And it would only send 1 stream to the US, and that's the primary in the US, which is only a primary, it's known as a forwarder, would send that redo stream to the US secondary. So basically it can have the network traffic or even further if you have more nodes than that. And you can daisy chain those together as long as your licensing can afford it, and build out a very robust solution. The biggest story around distributed availability groups, in my opinion, is for server migrations, because since they don't have to be the same cluster, it can be easy to migrate to a new version of the OS. Windows Server has made some advances in that. You can add, as long as you're on Windows 2012 R2 or higher, you can add mixed nodes. But in general, it's a good upgrade scenario with distributed availability groups. But DH2I and can support these mixed clusters. This is kind of cool. And just remember, like I said earlier, there's no difference between the files on Linux and the files on Windows. So I remember, like Oracle, I would have to, if I wanted to move a backup from a Unix server onto a Windows server, I would have to, either change the process or do an export and then an import. And there are limitations around the Indianness of the data. That is not the case with SQL Server. So, like I mentioned, I backed up a database on Windows yesterday, restored it to a Linux container. So Pacemaker is a scalable high availability cluster resource manager. This is used in conjunction with CoreSync cluster engine. So you install both of these products onto your nodes. And it's similar in concept to Windows Server failover cluster. It's a lot harder to do DR with, and it's also a lot harder to do automatic failover. And we're going to talk about that on kind of the next couple of slides. CoroSync does manage your quorum for you, and you'll have to, just like you would on Windows, you would set up a witness file share, or if you're building a failover cluster, you can set up a witness disk, just like you kind of traditionally did in shared storage solutions. The difference being a witness disk has to be always accessible from the SAN to those servers, where a file share only has to be network accessible. This all sounds great. It's documented by Microsoft on how to use this. I presented on it at Ignite a little bit a couple of years ago, and even the product manager for the product for high availability, and I had a hard time of keeping our demos in sync, because Pacemaker is extremely fragile. One of the big things I always like to talk about, and this is more me complaining from a demo perspective, but it's still something that was inherently frustrating to me. If the IP address of one of my nodes changed, my entire cluster broke. It's really, really tedious to use. Let's look at some of the limitations. So it's extremely cumbersome to set up and configure. The initial setup isn't too bad, but managing things like storage, managing certificates, so you have to create a certificate and distribute it to all your nodes. It's extremely tedious, especially if you're used to building, maybe a Windows Server failover cluster in about 5 clicks. It is not that. You have to do a lot of manual effort. You can script out some of it, but it's pretty manual. If you want automatic failover in your availability group, and remember, when we use automatic failover, we're using it only in conjunction with synchronous replication. So this is when we want like local high availability. So we want automatic failover in that scenario, so that if a node goes down, we can quickly be back online. The first requirement's not a big deal. The primary and secondary replica have to be set to synchronous for data movement. Same thing with the second, the data has to be synchronized. The third is really challenging. The cluster type is set to external, but the sequence number of the secondary replica has to become the primary. The secondary has to match the one from the primary replica. So this is just kind of more manual effort around configuring automatic failover. And the real killer to me in an availability group scenario is that Pacemaker requires a third node to maintain quorum and automatic failover, which, especially in a cloud world, increases your cost. Microsoft is generous and allows you to run what's known as a configuration-only instance of SQL Server. And this is something that I think is a big deal. Like, one of the things that the first time I demoed this was at SQL Bits, which is a conference in the UK that I look forward to going back to as soon as we can travel again. But so I was demoing a failover cluster instance, and the default mode of Pacemaker was to fail back after I did a failover. So somebody asked, what happens if you down the primary node? And I had just been testing failover, so I'm like, well, let's see. And so I took down the primary node in VMware, and the service failed over to my secondary like it should have. And we were watching and running some queries and such, and doing the normal things you do to demo a failover. And then as we were watching it, the node that I took down came back up and took possession back of the primary, which was unplanned and not really what I wanted to demo. So those things were kind of frustrating to me. This was one of the more challenging things I've ever done in terms of building a cluster. I rank it up there with the time I built a hybrid availability group in Azure back in 2013, kind of before anybody had done it in terms of challenging things I've done in my career. On the other hand, DH2I, and I don't want to make this sound like too much of a sales pitch. Yeah, it is. I'm telling you about this product, but I'm also telling you that I'm really experienced, and if for me to build a cluster in Pacemaker is going to take me the better part of a day. You'll see my demo here in a few minutes, but I built a cluster this morning in about the video is about 6 minutes. On Sunday afternoon, I did this the first time, and with figuring everything out and misunderstanding a couple of commands and docs, I'd say it took me about a half hour, which is still much, much easier than what you would have to do with Pacemaker. So we get easier automatic failover. We get simplified AG and cluster creation. So one of the really kind of cool things I liked about this is I didn't have to actively manage adding my databases to the AG. So as you'll see in the demo, I just simply created 3 databases, and then I ran a command line command, which you can very much do through the GUI. But since this was Linux, I kind of wanted to do everything through the command line. And boom, my databases were then added to the AG without me having to do anything else. So they were synchronized and everything. You have full professional support, full cloud support for Azure and Amazon in GCP, and very simple installation and configuration. And as we go into kind of demo mode, I'm going to walk you through my environment and how I have it configured. I just wanted to show you the AWS side of this too. And I don't, just full warning, I don't do a ton of AWS work because Microsoft pays me a little better. So I built everything on AWS for this. If I misspeak about any terms in AWS or use an Azure term, you can shoot me later. So this was the first step I did was DH2I has these free trial images. I used DX Enterprise on Ubuntu. I don't remember if I did 1804 or 1604, but we can look on the other slide, on the other browser tab rather. In here, I have 3 VMs. So you'll note I have these 2 DH2I VMs. These are both Linux machines. I didn't span availability zones mainly because I kind of wasn't paying attention when I created them. But you can span them across availability zones. Likewise, you could do the same in Azure. Here I have a VM to run SSMS in the Windows client. And here's just my configuration. Yeah, these were 1604. I didn't do 18 because I probably wasn't paying that close of attention when I deployed. But everything's running and available. And let's take a look at how we built out that availability group. So this is me this morning, just kind of doing what we had to do to build this out. So the first thing I'm going to do, right now we have 2 nodes that have SQL Server on them. And this is SQL Server 2019. So I'm running a command called dxci cluster add vhost. The vhost is kind of the fundamental construct. It's really effectively my cluster here. And I'm going to point that at the localhost IP address. And then I'm going to add my first node to this cluster. So there I created my vhost 01. This gives me a cluster that I have available. The next thing I'm going to do is add my node to this. And sorry, I'm cycling through my command history here. So here I'm saying sudo dxcli add AGs, this is actually creating my AG. So what I'm doing here is adding the AG to the cluster I created, and I added the SQL 01 node, and I'm resetting the port. So there's 2 ports. There's 5022, which is the traffic port for SQL Server. And what I'm saying here is in this command is add an availability group to this SQL instance, SQL 01. The instance name is MS SQL Server, which is what it's always going to be on Linux because you can't have named instances, but on Windows you could. Log in as SA. That QLCXI is my encrypted password. So the DXCLI command line utility provides you a password encryption, and so you don't have to pass in your command line, password of the command line. I'm saying send my AG traffic over port 5022 and use synchronous commit mode or availability mode, and then transfer the cluster traffic over 15022. So that runs. At this point, I have an AG. I don't have any databases yet. What I want to do first is add my other node to this cluster. So I'm going to secure shell. Actually, I'm going to generate a one-time key to add my other node to the cluster. This is how the intra-cluster node security is done. So this is a one-time pass key. I can see how long it's good for. I'm going to copy this. And then secure shell over to my second node. Here I'm going to join the cluster. It does specify, we do specify this NAT proxy. This is just part of the install where we're saying match dh2i.com. And then I'm going to enter that passkey. Now this server is added to the cluster, but this SQL instance is not yet a member of my availability group. So we're going to do that next. Just changing the port number around. So all we're doing here is adding, we're running the same add AG node command, except we're adding this SQL Server instance. So if you look where my mouse is, you'll see SQL 02. And I use the same SA password, and I'm just going to change this port to something else. The ports for each node, not the transport port, but the cluster port are unique in the instance, or unique in the cluster, I should say. It would help if I hit play there as I change my port number. And then we've added this instance to the clusters, or to this instance to our availability group, I should say. So that's all we had to do that. And what we're going to see next is I'm going to log out of this node and then go back to our 01 node and create some databases and then add them to the AG. So here I'm just going into SQL CMD as SA. I think my SQL CMD use has dramatically increased since SQL Server on Linux came out, just because I don't always have a GUI installed on my Linux OS. And so here, all I'm doing is creating free databases. And to me, this is one of the more powerful parts of this demo, because if anybody's done this before, they'll know this process. So now I'm going to exit SQL CMD and then run this command to add these databases to the availability group. And if you've done this before, whether it's manually or through streaming, you know you have to have a backup of the databases, have a log backup of the databases. Here, all I'm saying is add my databases to this cluster, this availability group, and then the database names. As soon as I do this, all of my databases are going to be added to both of my nodes. Obviously, this is going to take a little more time if you don't have empty databases, and it helps if you type the command right the first time. It's databases, not database. But I left this in to show you that I make typos too. So now, as soon as we're done with that, we have our databases and they're in this availability group. So that's really, really kind of awesome. The next bit of functionality we're going to use here is and this is only supported on SQL Server 2019 because cluster type of external didn't support a listener in 2017, but we're going to add a listener here. And we're going to say vhost1 and then AGO1, and vhost is going to be our listener. And we're going to use 31.4.33 as our port. And I need to run that command as sudo. So that's why I got that encryption message. And now we've added an availability group with the listener. So let's go over to our Windows machine and take a look at what that looks like. Sorry about that, I'm having zooming issues. But let's zoom in. So here we see our cluster. Actually, that zoom doesn't work too well, but we see our cluster, we have our 2 nodes, we have our availability group. And if I go to Management Studio, I didn't refresh this since I built it this morning. I see that I have my 3 databases here, and they're all synchronized. And likewise on DB2. So if I go into the availability group and expand that out, I see that SQL 01 is the primary. And if I click on properties of the availability group, I can see that the cluster type is external. I can see that both of my nodes are synchronous commit. And I can also see that I have an availability group listener here called vhost1 that we can connect to. Right now it's localhost because I didn't go through the process of creating an additional node to IP address rather to bring online. But one thing that's kind of unique, because our cluster type is external, in Management Studio, you'll notice that the failover button is grayed out. Let me try to zoom one more time. There. So you can see that that failover button is grayed out. However, so what that means is we're not doing failover through Management Studio. The way we do failover here is through this cluster. So here, if I want to say, this is the DX admin solution that allows us to manage the cluster. So here we can see our virtual host. I can remove a virtual host. I can stop. I can freeze my nodes. I see my availability group databases, so I can manage my availability group databases. I see they're all online here. And I can see my cluster nodes. And here I see the IP address and all the supporting information. And I can see that my availability group is on AG01. And here to fail over, I can right click on the second node and say start hosting on node. And that happens pretty quickly. And if we go back to Management Studio and we refresh, sorry, can't refresh from that view. I now see that AG02 is my secondary. So it's a little bit different in that you manage the failover from here. But likewise with Pacemaker, you would manage the same way. But we have all of our information about our cluster here up and available to us. If you're more comfortable with a command line interface, which I know a lot of Linux admins are, you can use that. But this GUI also makes it quick and easy. We can also see that this is healthy because we have this green indication here to get our full detail for our cluster. So in terms of the AWS part of that, that was pretty trivial in terms of everything I had to do to build it. Like I say, I'm pretty green at AWS, so I was able to go in on Sunday afternoon in about an hour and build out my AWS VMs, get SQL Server installed. Because the DH2I software is installed, I didn't have to really do anything other than run a shell script to do setup. And then I was up and running with my availability group in an hour or so. I had a couple of questions. Like we mentioned, support's really professional. I was building stuff on Easter Sunday afternoon, and I emailed support because I ran into a command line thing I didn't understand, and they got back to me very quickly. Very, very nice, complete solution. So SQL Server on Linux is quick and easy to install and configure. I think this might be its biggest benefit. The Windows operating system has come a long way in terms of performance and security. And it's pretty robust. There are some things that annoy me around the edges, but it's not like it was back in the Server 2003 days, where I can legitimately make an argument that Linux or Unix was a whole lot better. But there are a lot of things that are easier in Linux, just especially things around server automation. So being able to do things repeatedly in a command line manner still can be a little bit easier. And I know I'm going to get yelled at by PowerShell people on the call. It's light years better than it used to be, but I think a lot of that comes from the fact that folks that operate Linux are used to doing everything from the command line always. So there are a lot of merits and benefits to using SQL on Linux, especially if you're a shop that mainly uses Linux servers or you want to use containers. The container thing we didn't talk enough about today, but Kubernetes is really interesting to me, especially from a high availability perspective and just some of the things you can do with SQL Server and deployment automation. And yeah, I know you can run Kubernetes on Windows. You can have Windows nodes in your Kubernetes cluster, but I'm still of the opinion that if you're running Kubernetes on Windows, you're going to be one of the only people who are doing it, and it's going to be not a really great experience. So that container scenario is another one where you really want to think about using SQL Server on Linux. I would actively recommend you not to try to run SQL Server containers on Windows. Just it's not something that anybody's doing a lot, and so you're going to be kind of out on an island by yourself. Similarly, I think one of the biggest problem that's held back widespread adoption of SQL Server on Linux, and this is from just about every customer I've ever talked to about it, is that Pacemaker is kind of a not great piece of software, and that's me being really polite. I have far worse things to say if we could meet at a bar and have a couple of beers, which I'm sure we'll do in 2021. But it's extremely challenging to implement and maintain, and it lacks one of my favorite terms, which is stoneth, or depends on stoneth rather, shoot the other node in the head. It doesn't work real well in the cloud, so that means you can have additional problems with automatic failover. And DH2I offers an excellent alternative that you can have up and running in less than 30 minutes. You saw in my demo, I actually slowed down that demo a little bit, so we paused a couple of times. The total time it took me to build this out this morning was about 5 minutes and 20 seconds. So I slowed that down to about 6 minutes so we could talk through it a little better. But that's how quickly you can be up and running. And not only that, if you're still a Windows shop and you want to just ease your management of availability groups, DH2I is available for Windows too. You notice like the really two powerful things I thought that I did in that demo were adding those databases to the availability group and how quickly that happened, and then adding a listener, and that was that simple to do, because those are both things that are not inherently easy, and having all that internalized and automated for you behind the scenes can really improve your productivity as a DBA. And with that, I'll hand back to Connor we'll talk through some questions and any other questions that you guys have during this meeting.
Excellent. Thanks so much, Joey. So again, if you have questions, go ahead and type those on in. We've got a couple that have come in throughout the presentation already. So we'll start with one. Somebody wants to know, where can I see the logs for this tool? And Joey, I'm not sure if you experience any, digging through our logs or anything like that, but all of our logs are logged in Journal CTL. So that gives you a really nice kind of one place to find those different logs, everything that's happening in the cluster. And then we also have another tool where you can actually collect the logs for a particular node. So it'll grab all the logs and put them in a zip file. And so you can always take that zip file and send it to our support group if you have any additional questions or things like that. And we can look through those logs as well. Let's see. So somebody wants to know, Joey, when did you create the endpoints and the certificates for the availability group cluster?
I did not have to do any of that. That was kind of the beautiful part. The only thing I had to do that I didn't show you because I did it on Sunday was I had to make entries in the Etsy host file. So like if we go back, let me see if I have a terminal window open. I think I was logged in. Let me kill PowerPoint. I promise I have a Linux window open. There we go, and we're logged in. So here, that was the only thing I had to do here was I had to set the name of the host. So I have this is SQL 01, and I have the second entry for SQL 02. Other than that, I didn't have to do anything in order to I didn't have to create the certificates. I'm assuming you guys sign that with some of the encryption key, or not encryption keys, but encrypted passwords we use, and that's what generates the certificates.
Yep, exactly. So that's all done automatically on your behalf, and it takes a lot of that complexity out. As Joey, I'm sure you've experienced with Pacemaker, having to manage those certificates yourself and set all that up. So we just kind of do all that behind the scenes.
Yeah.
Let's see here. We've got another one. Somebody wants to know, can failover only be done by command line method only, or will the UI also work?
Yeah, I did the failover via the UI. I didn't use the command line for that. There's a command line option, but the GUI will support it.
Okay. Let's see, we've got another one here. This is related to Pacemaker, and it says, where can we go for support for Pacemaker if the cluster service itself has any issues?
Is Pacemaker supported by Red Hat? I'm not 100% sure. Or is it only community?
Yeah, my understanding is that you can get Pacemaker support through Red Hat, but of course that would require a subscription and support through them.
Yeah. Yeah, in my experience, it was mostly, I didn't have support when I was building that stuff, and it was mostly chasing forum posts around the web and or bugging people on the product team, which I'm fortunate enough that I can do, but I know not everybody can, so that's not a great solution. Mahela doesn't scale.
Right. So let's see, we've got another one here, I think for the DH2I side, just what is the general price of the DX Enterprise tool? So this kind of depends on, the answer is always it depends, but really for the availability group solution, the price for that is around $1,500 per server per year. So it's an annual subscription, and that comes with support. So we try to keep kind of the price at a reasonable level because we know people are typically running Enterprise Edition of SQL Server for this. So that's kind of where the pricing comes out. Let's see here. Somebody says that they noticed that the instance was a default instance. I know we can't have a named instance on Linux today. Is that something that, Joey, you see changing in the future, or have you heard any rumblings about support for a named instance?
I have not heard any rumblings of support for named instances on Linux. Given the push that Microsoft is making towards containers, it's not something I would see coming. But if you're a big customer, ask, because that's how things change. Yeah, I mean, that's not something I in all likelihood see changing anytime soon, but you can, like I say, especially if you're a bigger customer, I'm sorry if you're not, that's just kind of the way that works. Definitely voice that to your support or to your sales rep, because that's the way changes get into the product.
Right on. So somebody wants to know, and this is kind of outside of the availability group discussion, but can I fail over a SQL Server instance itself between Windows and Linux?
Do you guys support that with your FCI?
So we don't. So it all comes down to the application itself. So if there's an application that can run on both Windows and Linux, then we can absolutely control failing it over. But because of the differences between Windows and Linux, it's not something that's supported.
Yes. So Microsoft initially announced that SQL Server 2019 was going to have support for master and MSDB and always on availability groups. I'm not breaking NDA by saying that because they announced it today night. It did not make it into the GA release of 2019, obviously. That could drop at any time. I know there's like active work being done on it. I can't obviously state anything about product roadmap there from Microsoft, but it was something that was planned and there was some work done. And it's kind of supported in big data clusters. So in that scenario where you could have a mixed availability group, you could do that between Windows and Linux, but it's still not quite the same as like instance failover, where you would be failing over the whole, like a failover cluster instance.
All right, looks like we've got another one. Is there a trial software for the DX Enterprise tool? And the answer is yes. I hesitate to use the term trial software because it's actually fully featured software. It's just kind of time restricted. So if that is something that's of interest to you, you can certainly reach out to us at DH2I, visit the DH2I website, and follow the links there to get access to a trial, and we can help get you stood up and test things out.
Or use the Amazon image. Yeah.
Yeah, exactly. So we do have the AMIs that Joey's got up there. You can definitely go in there, and there's a free trial on those as well. I think it's a 15-day trial or something like that. And so you can just go in there and start playing for free and see if you like how things work. All right. Well, go ahead.
Yeah, I was just going to say I built just exclusively on this the other day, so that's exactly what we did.
Cool. All right, so it looks like that's about it on the questions. We'll be following up with everybody who attended the webinar today and those that also signed up and didn't make it with the links to the recording, so you can go back and take a look at the session itself and share it with colleagues and things like that. So we'll look out for that email a little bit later today. And again, reach out to DH2I or to Joey if you've got any other questions that come to mind. And I just want to thank you, Joey, for joining us today and presenting this webinar, and thank everybody else for attending.
Thanks, Connor.